I'm Dr Carl Spingys. I'm a physical oceanographer at the National Oceanography Centre, and I'm leading the ARIA project called Full Ocean Fibre. So the deep ocean is one of our least observed environments on Earth, with large parts completely unobserved. This means there are significant gaps in how we understand how climate change is affecting the deep ocean. The good news is that there's been some recent technology developed called distributed optical fibre sensing. What this does is it converts an optical fibre cable, so the same kind of cable that the internet works on, into many sensors. What we propose to do is use the vast network of these cables that already exist on the seafloor as a new approach to measuring the deep ocean. And what this allows us to do is make a huge range of measurements, from very dense measurements every metre and 1,000 times a second over regions near the coast, to measurements over much longer distances, over thousands of kilometres over the North Atlantic. So in our project, as part of the UK's Advanced Research and Invention Agency's Forecasting Tipping Points programme, we're going to develop the vital ocean sound and fingerprinting techniques that we need to convert this near-floor cable measurement into telling us stuff about the ocean, either close to the cable or through the whole water depth. And we're going to do this by bringing together a diverse team of scientists, from people that work in ocean sciences, trying to understand the ocean physics, people that work on seismics and how the ocean floor works, and people that work on the fundamentals of how to make these measurements on cables. So these techniques we develop will give us a brand new view on how the North Atlantic works, and they'll also set the scene for the next generation of ocean observing network.